Good day, viewers. This is Olasunde Akins on YouTube channel Simplify Maths. About indices like Samuel G. Hart. Subscribe. Lesson 1, Indices 1. Samuel G. Hart's interest in chronology and indexing emerged from his scholarly pursuits and meticulous nature as a 17th century merchant and diarist. Immersed in local events and literature, he recognized the value of organizing information for personal and scholarly use. Living through historical shifts like the English Civil War, he understood the importance of accurate record keeping. Jazz dedication to detailed organization contributed significantly to the development of indexing practices, enhancing accessibility to various texts for himself and others. Whoa. Lesson objectives 1. Laws of indices. 2. Applications of the laws of indices. 3. Further examples on laws of indices. Under this, we have simplification of expressions on indices, rational indices. Laws of indices. The following are the laws governing the mathematical operations involving index numbers. The laws are: number 1, we consider the first law. AX times e raised by y equals a raised to the power x plus y. This could be in form of this. Assuming we have 6 raised to the power 4 times 6 raised to the power 2. Since they are having the same base in indices, it equals 6 raised to the power 4 plus 2 equals 6. Then let's consider laws. Second law of indices. We have e raised to the power x divided by e raised to the power y. This equals to e raised to the power x minus y, and this could be in form of this: 5 raised to the power 3 divided by 5 raised to the power 2. Indices. Since the bases are equal, we subtract the index. Then it becomes 5 raised to the power 3 minus 2, and that will give you 5 raised to the power 1, which is equal to 5. Let's consider another law now. The third law tells us that a raised to the power minus x equals to 1 over e raised to the power x. In reality, in mathematics, we can have it this way. Let's say we have 6 raised to the power minus 1. This is equal to 1 over 6. Another law, the fourth law, tells us a raised to the power 0 equals to 1. Anything raised to the power 0 in indices is equal to 1. We may have 1,000 letters or whatever it is. Let's say 100, for instance, if this was 0 is equal to 1, or maybe mathematical expression, we have it this way: 5 equals 0 times 50, for instance, that is equal to 1 times 50, because anything equals 0 is 1, 5 equals 0 is 1 times 50 equals to 50. Now let's go to another law. The fifth law of indices tells us, number 5, e raised to the power x into power of y equals to e raised to the power x times y, which is equal to a raised to the power xy. Then we can have it this way now. Let's say we have 4 raised to the power 2 raised to the power 3. This simply means 4 raised to the power 2 times 3, which equals to 4 raised to the power, which equals to 4 raised to the power 6. 4 raised to the power 6. Or we may have it this one. Let's say we have 3 raised to the power 2 into power of 2. This will give us 3 raised to the power 2 times 2, which is equal to 3 raised to the power 4. Now let's go to the sixth law of indices. The sixth law of indices tells us a raised to the power 1 over n, because m, for instance, maybe is equal to m into power of a, and this could be in this form. Let's say we have 64 raised to the power 1 over 2 This simply means square root of 64, which is giving us plus or minus 8 as the answer. Now let's look at the final law of indices. The final law of indices number 7 now tells us a over s over y equals to y root of a, then bracket what? X. In reality, mathematics, we may have it this way: 64 raised to the power 2 over 3. This will give us cube root of 64, then everything raised to the power 2. The cube root of 64 is 4. This 4 times 4 and times 4, that's 16. The raised to the power 2 will give us 4 in two places. That's the first here, which is 4 times 4, and that will give us 16 as the answer. Now we go to the next level. Let's look at examples, applications of the laws of indices. We look at some questions here now. Let's look at this first question. If 27 raised to the power s times 3 raised to the power 1 minus s over 9 raised to the power 2 is equal to 1, find the value of s. When you are solving this problem, you have to reduce everything to 3 base of 3 to be able to solve it through the use of indices law. So 27 raised to the power s will give us 3 raised to the power 3x times 3 raised to the power 1 minus x, then 9 raised to the power 2x is equal to 3 raised to the power 2 into 2, that is 2x into 2, which is equal to 1. Now in this numerator now will give us 3 raised to the power 3x minus x plus 1 over the 2x times 2 will give us 4x, that is 3 raised to the power 4x is equal to 1. Then 3x minus x is 2x, so this will give us 3 raised to the power 2x plus 1 over 3 raised to the power 4x equal to 1. Then let's go to the next page to continue. So it's going to give us 3 raised to the power 2x plus 1 over 3 raised to the power 4x is equal to 1, and this over 1. Then you can cross multiply this. This will give us 3 raised to the power 4x is equal to 3 raised to the power 2x plus 1. That plus 1 is the same as times 3 raised to the power 1. Then there we have 3 raised to the power 4x over 3 raised to the power 2x equals to 3 raised to the power 1. That is 3 raised to the power 4x minus 2x. It gives us 3 raised to the power 2x is equal to 3 raised to the power 1. And therefore it means 2x is equal to 1 because the bases are equal. Then s will give us 1 over 2 as the answer. Let's go to the next question now. We look at another question, question 2. Solve 47 over 125 bracket minus raised to the power minus 1 over 3 times 4 over 9 raised to the power half. In solving this problem now, in the first place is negative sign. In indices, to convert this one to cancel this one will be converted to positive by turning this upside down. That is, it becomes 125 over 27 raised to the power 1 over 3, then times 4 over 9 raised to the power half. This will give us cube root of 125 rather. This will give us cube root of 125. That's cube root of 125 over 1 over 27 times 4 over 9 raised to the power half. The cube root of 125 is equal to 5. You multiply 5 in 3 places, you give 125. Then 27 to root of 27 is 3. Then this one is times square root of 4 over 9. And that is 2 over 3. So let's go to the next page. Give us 5 over 3. Going to give us 5. Going to give us 5 over 3. It's giving us 5 over 3. As we have in the last page. Last page we have 5 over 3 times 2 over 3. 2 over 3, which is square root of 4 over 9 times 2 over 3. And this will give us 10 over 9. And this will give us 1, whole number 1 over 9 as the answer. Now let's consider another question now. Question 3. Still under indices. Given that 5 raised by n plus 3 over 25 raised by 2n minus 3 equals 5. Find n, that's the question. Then in solving this problem, we have to reduce everything to the base of 5. Since it is indices, to be able to apply it successfully the indices law. Then we have 5 raised to power n plus 3 over, we have 25 is 5 square, then into 2n minus 3 equals to 1, because anything raised to power 0 is 1. Then cross multiplying this will give us 5 raised to power 2 into 2n minus 3 equals to 5 raised to power n plus 3. And since the bases are equal, what happened to index the index are equal? You can multiply this one out, giving you 2 times 2n times minus 3 will give us 5 raised to power 4n minus 6 equals to 5 raised to power n plus 3. Then let's consider the continuation. Let's continue. In the next page, since the bases are equal, the index are equal, therefore 4n minus 6 is going to give us n plus 3. 4n minus 6 equals to n plus 3. So in this case, we have 4n minus n equals to this side, going to negative. This minus will go here, we move to the next side, will become positive. Is equal to 6 plus 3. So we have 3n equals to 9, therefore n equals to 9 over 3, and that is equal to 3. So our n equals to 3. That's the answer. Now let's consider the next question. Simplify. R raised to power s raised to power 2 over 3, everything raised to power 3. In solving this problem, you can have it this way. Half raised to power 3 itself, because everything inside the bracket is raised to power 3, then we have s 2 raised to power 3, then raised to power 3. This 3 will cancel 3, with remaining 2. Then half raised to power 3 is 1 over 8. That's half in 3 places, 1 over 8. And this one will give us x square. If after cancelling these 3 remain 2, so it becomes 1 over 8 s raised to power s square as the answer. Let's consider another question on that is indices. Simplify 3, 1, 2, 5, 3 raised to power 1, 2, 5, every 3 raised to power 1 over 5. How do we solve this problem? 3, 1, 2, 5 itself is 5 in 5 places. That is 5 times 5 times 5 times 5 times 5. Then it times 5. That's then that's 5 in 5 places. 5 times 5 is 25. That's 5 times 5, 25. 25 times 25 is 1, 625. Then 625 times 5 will give us 3125. Therefore, solving this problem, we have 3125 will result to 5 raised to power 5. Then we have till raised to the power 125. Then everything raised to the power 1 over 5. In solving this problem, you can have it this way: 5 raised to the power 5 multiplied by 1 over 5 by law of indices. Then we have times t self 1 over 25 times 1 over 5. 5 we cancel 5 here, will give us 5. Then 5 L1, 5 into 8 is 2, 10 into the 5, 5. So the answer is 5t raised to the power 25 as the answer. Thank you. Subscribe.